Alright, the main point of this is to show you how and where to pull values from SOLIDWORKS for this calculation, but I'll run through the fatigue calculation one time too. This is a straight application of miners rule, which if you recall is a way of basically counting damage accumulation. At higher stress levels above the endurance limit, the part will have a smaller life. So if you're subjecting a part to varying stress levels, up and down, the life in total depends on the number of cycles at each stress level. So in Miner's rule itself, the general form, which is here, the lowercase n's are the actual number of cycles at a stress level, and the uppercase n's are the allowable number of cycles at that stress level. So to be able to solve something useful here, I'm assuming a relationship between all three load cases. So the total number of cycles at the first load case, which is just running on rough ground, is N1. The total number of cycles at the second load case, which is landing on two wheels, is 20% of N1. And then the total number of cycles landing on one wheel is 5% of N1. So basically it's always going through the stresses of N1 constantly, but occasionally, 20% of the time, you add in that bump, and 5% of the time you add in the one wheel hit. So that way, when you drop these three values in the Miner's rule, all you have on top is N1 as an unknown, so you're solving for the total life of the swing arm. So that's pretty handy. And these capital N's, this was a typo in the original handout I sent. I'll send a correction with this video link. The SF values here, those are what are actually being calculated in the finite element analysis, and that's what you're pulling. And the important thing there is that you want to pull for any location where you're calculating life, you're pulling stresses from each load case at the exact same point, which will be a node. And you're going to want to examine multiple points due to different local maximums, but for any application of Miner's rule, you're always calculating these N1, N2, N3 based on stresses from the three load cases at the exact same point. So looking at SOLIDWORKS, here's my model. I'm going to go to the rod loads. I'm going to turn off all the graphics and plot the von Mises stress. Now I've defined, knowing how the part actually fails, I know that I'm considering the area about the weld itself. It could be on either side. You kind of have to poke around to figure out where it's actually worst case. But one thing I'll say, it is very useful to have discrete plots turned on, which I do currently, and it's also useful to have the mesh turned on, and all of that's available. There's discrete, there's show mesh. The reason that's useful is when you grab the probe tool and start looking for the local maximums, it's really easy to see where everything is, so you don't have to do any guesswork. So for this load case, I've been through this before, so I'm pretty confident that that is the maximum stress right there, 7,875, and that occurs at node 3,440. So when I go to the second load case, I want to be pulling stresses directly from that same node. And luckily, you do have to exit the probe tool here to switch to the second load case, but everything's in the same orientation. So if I turn the mesh on here, I remember roughly where that node was. I should be able to pick it directly. So there we go. Exact same number of node. And here the stress is 14,770. So that'll be the value I use to calculate N2, capital N2. And then finally, same thing in the last load case. Exact same node. I think was that one. Yep. There we've got a stress of 22,580. So those three stresses, and I've forgotten what they are, but those can be used for one application of Miner's rule, which will determine the total life expectancy at that point. Remember, you're not calculating life expectancies due to load cases. You're calculating them due to, or you're calculating them for any point at in the model, but due to all three load cases. So that was that one. This model, the maximum stress is somewhere in this upper corner, and this is one I would need to put a fillet in there and refine it to get a true maximum, and I'm not going to go through that in this video. but we'll just say that corner is the maximum for this load case, which is node 149 with a value of 65,370. So this would be a totally separate application of miner's rule. And I do it the same way. I take that stress, I go to the next model, grab the stress at the exact same node, 48,360, go to the first load case, do the same thing. $25.79, and with those three stresses I can apply miner's rule, calculate the total life N1 of the part at that location. And essentially what I'm looking for is the location where the total life N1 is lowest. That's what I'm after. I'll make one note real quick. Well, there's several notes down here that you can read through, but the one thing that I wanted to point out was stresses that are below the endurance limit do not cause damage, because the capital N that you would calculate is infinite. That's the definition of infinite life. So all of the stresses that you're going to find in that region for the first load case, certainly this one, is below the endurance limit. I'm getting an endurance limit between 11 and say 15,000 for this material with this heat treat, and 2580 is definitely below that. So this would actually not cause damage in this instance. That's okay, this term drops out, but you still have the other terms which drive the true value of N1. So you might ask, why would you even include the stress effects of N1, or why would you bother with that load case if it's not leading to damage? The answer to that is it's not leading to damage in this model, but depending on the changes you make, it very well could lead to damage. And one last thing further to that, in my model, as we've stated before, I'm ignoring areas. We've got high stresses in this load case out here. There are some stresses in this load case that are above the endurance limit, all along this beam, for instance. But I know in my original model where failure occurs, so that's where I'm focusing my analysis. On your redesigns, your own designs, that's not necessarily going to be the case. So you may have to examine some other areas. And it's entirely possible that you'll have critical areas where stresses due to this first load case are above the endurance limit. And once you get your models built and get some results out, you just have to poke around with them. Feel free to ask either Garrett or myself questions, and we will help you as best we can.